Bismillahirrahmanirrahim. The work that we have done so far about these special lines in a triangle were basically laying the groundwork or the foundation for what we're going to talk about now. And what we're going to talk about now, I think, is actually very, very cool. We're going to start out by talking about each one of these individually, the special segments. And what we're going to talk about today of these is the perpendicular bisector. So what I've drawn here is a triangle, and I'm going to draw one of the perpendicular bisectors. We're going to start off with this one over here, and of course I cheated here a little bit and done some of the work before. So here's the perpendicular bisector of segment AC here, of this triangle. So we know that since it's a perpendicular bisector, those two are going to be congruent, and that's a right angle. Okay. Now, what we do know about a perpendicular bisector, and from the perpendicular bisector theorem, is that every single point that's on the perpendicular bisector is equidistant from the endpoints of the segment. So if I were to pick this point over here, that point would be equidistant from the endpoints of the segment AC. You would agree with that, right? So if I draw this point over here, and from there to over here, these two would be congruent, correct? Because every point on the perpendicular bisector of a segment is equidistant from the endpoints of a segment. Okay? Then what I'm going to do is I'm going to take side AB and draw its perpendicular bisector. So here it is, and as I said, I've done a little bit of the work already, and that's the perpendicular bisector that corresponds to segment AB, and that would be this segment here would be congruent to this segment over there, like that. Okay, now the two perpendicular bisectors that we have constructed they intersect at that point. Now, just like I had suggested that that point would be equidistant from AC, from here to here, that would be equidistant from AC. Similarly, I can suggest to you now that this new perpendicular bisector that I have created, every point on this perpendicular bisector right here would also be equidistant from segment AB, right? Correct? So including this point. So if I were to draw this point over here from here to here, for example, and here to here, and looking at this segment over here, AB, so this point right here would be equidistant from AB, right? So we got that. So we got the two perpendicular bisectors so far. Okay, we're going to get back to that. And then we have a third side of this triangle to contend with. Okay, so I'm going to do the same thing. I'm going to draw the perpendicular bisector from this side, and it's going to be like this. Oh, wow. And we know from before that they are all concurrent, meaning that they meet at the same point right there, a point of concurrency. So that's the point of concurrency of the three perpendicular bisectors. So now we can say that this is going to be congruent to this. I made it a little neater, and we can say that this is going to be congruent to this. So these are all perpendicular bisector, and this here is the point of concurrency. Okay, so point of concurrency, right? All right, got it. Now look, that point of concurrency is no ordinary point. Okay, now we had suggested that this point is going to be equidistant from this endpoints AC right here. Okay, like this. In other words, this point right here, this segment here, let's call this point how about point P? Okay, so right, so let's call that point P. So segment AP is going to be congruent to segment CP, right? So we can label this, I don't know, let's call that 1, 2, 3, 4 like this, and 1, 2, 3, 4 like this. But then this point P is also going to be equidistant from AB right there, right? Because it's on the perpendicular bisector of AB, so it's going to be like this. But now we gave these 4 ticks over here, so we're going to have to give this one 4 ticks over there, right? And the same point is equidistant from BC, but we already marked it. And lo and behold, what you observe is that this point right here, point P that we have suggested, is a very, very special point. in that it is the only point in the triangle, in fact. It is the only point in the triangle that's equidistant from all three vertices of the triangle. It's the only point that's equidistant from the three vertices of the triangle. Okay, now hypothetically, let's say if I gave these segments P, that's PC and PB and PA, I'm going to call them R over here. Okay, I'm just going to give them a name. I'm going to call them R right here. Now you observe that A, P, C, B, P, and B, so they're all the same length. They're all R, right? Now, this point P, we actually give this a name. This point P is called the circumcenter. Okay, you have to be careful how you pronounce that. P is the circumcenter of the triangle. C-I-R, circumcenter. In other words, it is in fact the center of the circle that the triangle is inscribed in. Look, I'll show it to you. So what I have here is a stencil thing, okay? So I'm just going to drag it, and I'm going to put the center of the stencil thing right here. I wish I had better circles to make, but then make sure this center is, aha. Now watch, okay? Just watch. Then what I'm going to do is I'm going to try to color this thing for you. What color should we pick? Well, we've been picking that. Let's make that a nice purple because we picked up purple. So let's color this purple like this. Okay. Make it nice and purple circumcenter like this, okay? See, there we have it. There we have it. Okay. So this point is very, very special. The intersection of the three perpendicular bisectors, because all the points in the perpendicular bisector are equidistant from the endpoints of their respective segments. And since this point is the only point that's equidistant from all of them, this point is the center of a circle that goes around or circumscribes. So there's some terminology associated here that we shall learn. We say the triangle is inscribed. The triangle is inscribed in the circle. And then we say, and you can call this circle P. We say circle P circumscribes. C-I-R-C-U-M-S-C-R-I-B-E-S, circumscribes the triangle ABC. Okay, it circumscribes the triangle ABC. Okay, now, and this center is called the circumcenter. So the point of concurrency of the perpendicular bisectors is the circumcenter. It is the center of the circle that circumscribes the triangle, and the triangle is inscribed in this circle. And this point of concurrency, therefore, is very special. And inshallah, next time we shall explore these concepts even further, and you will see some remarkable geometric phenomena. Until then, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.